Good morning, everyone. This is Cassie Stumo. I am the marketing specialist here at EAC. We will start off today with an intro of EAC from one of our Mathcad gurus, Jenny Wilson, and then Paul Dye from PTC will be presenting to us on an overview of Mathcad Prime. Everyone gets a recording of the session pending any technical difficulties. Please feel free to ask questions along the way, and we'll answer them after the presentation. We will have a short survey that will appear once the webinar is over, so please just take a minute to answer those. And I'll go ahead and hand things over to Jenny.
Awesome. Thanks so much, Cassie. Welcome everybody that is attending this webinar. I just wanted to give a brief, quick, who is EAC? What do we do before we kick off into Mathcad, just for you guys that aren't really aware of what we do and who we are. So first of all, at EAC, our mission is to transform the way companies design, manufacture, connect to, and service their products. We're not only a value-added reseller for PTC, but we're also the #1 solutions provider for PTC in the country, with experts in roughly about 22 areas of product development. So we're located all over the United States with our headquarters in Minneapolis. Some of the things that we offer to our customers is everything that they need in really the product development process, such as Creo, service life cycle management software for managing service documentation, software that helps you manage your product data, such as like Windchill, ThingWorx, Navigate, and our customizable EAC productivity apps. We also implement the Internet of Things and augmented reality into business strategies to jumpstart some of your initiatives around digital transformation and really starting to connect all things in your company. We also assist with design and engineering projects like FEA, simulation, reverse engineering, and working with proof of concepts for customers. So if you are experiencing any bottlenecks within your organization, we can definitely help out with that as well. And lastly, we offer things like webinars like we're doing today, but on top of that, we also do some in-house training, on-site training, or remote mentoring for individuals that may need some training on the softwares that they're using today. And on top of that, beyond training and stuff like that, we also are partnered with a company called Formlabs. We're a commercial reseller for them, and they offer their latest products in additive manufacturing. If you guys are doing any kind of prototyping, sending it out, and you want to bring that prototyping back in-house and save some money, the Form 3 is now available with packages starting around $3,500. So that's kind of where we are and what we're doing. So just keep us in mind. If we have solutions that really help your organizations save time and money throughout the product development process. So keep us in mind. If you have any questions on any additional things that we do here at EAC, feel free to reach out. But I just wanted to let you know what we do, and then now I will transfer it over to Paul and have him get started on the Mathcad webinar. Thanks so much.
Hey, thank you, Jenny. So again, my name is Paul Dye. I'm here to represent PTC on behalf of Mathcad Prime. So the focus of a lot of our talk today is going to be centered around the engineering process. So we have to document exactly what we're doing, might have calculations, and an intellectual property that defines how that all works. These days, there's a lot of different ways to do it. You have spreadsheets, computer automation, maybe just pencil and paper. Maybe you have thick reference manuals that you have to sift through to actually get through an entire process. And most times we see those resources are pretty spread out across the entire company with little to no reuse or any of that documentation. And that's just because there's in so many different places and different formats, and oftentimes it gets lost between projects or new teams that form. Whether we're transferring those resources or working on it ourselves, errors sometimes are pretty hard to spot. An example of this was the Mars probe. So you may have heard of this. It was 2 different teams, 2 different areas, 2 different sides of the world. They ended up working on different parts of that Mars probe in different units, and ultimately that caused the project to fail and crash into the surface of Mars. And maybe cost millions of dollars, and it was really something that was completely avoidable. And with that, we want to fix those type of problems. The way that we're going about that is with Mathcad Prime. So this process is really made up of analyzing, solving, documenting, and sharing. We'll dive into that in a minute. But at its base, Mathcad is a digital engineering notebook, and we use it to perform calculations and manage design intent. And this picture up here really shows this. So it's more of a document, and it's very visual. So we have things built into it like graphs and calculations, notes, and very visual. It's not a bunch of code and computer programming like you see here. It's not what it is. It's not something we have to sort through to try to understand. That's not to say that Mathcad doesn't have a very powerful engine running at its core, though. But as the user, we're not going to have to worry about any of that. We just work in a neat and robust interface and let the documentation do all that work behind the scenes. When we're working with Mathcad, we have what's called a whiteboard interface. So this is where we're stamping all of our work onto, and the default is this nice grid style paper that we're used to working in, something like an engineering notebook. And it also does out calculations for us. Whenever we lay out equations, and provided that we give the necessary values, it's going to automatically give us the answers with no need to code out a single thing. This document essentially has everything built right into it. Live math, text, graphics. You need to call up other different programs, which we'll actually see a little bit later on. And it isn't all for calculations. Remember that we do all this to display the design process in an easy to understand manner. Very useful feature that we have in Mathcad is the ability to manage units. So say you add 9 inches plus 2 feet times 8 furlongs. It understands every single one of those and outputs into whatever units that the user actually needs. And one of the big things to note is that everything that we do is self-documenting. So we can do out all these calculations, do all the work we need, and once we're done, all the documentation is right there in Mathcad. Really simplifies that process. Working with Mathcad is very much WYSIWYG. So what you see is what you get. Not different formats for printing and all that, just a page that you work with. And in that page, there's a huge function library that we can use. Math notation, solvers, data analysis, statistics, Fourier transforms, all these things that maybe we studied and could have some knowledge on, but luckily Mathcad can do all these things for us. Just have a lot of different plot options, simple XY plots, polar coordinates, contour plots, it's all right there. Also, these are all live plots. So whatever data is on the page, if you change things around, the plots are going to update to show those changes. One of the biggest things that we strive for in all the products working with PTC and EAC is the ability to coordinate and work together between programs. So we can take programs or take values from Creo, put them into Mathcad, do some calculations out, and then go ahead and send them back. And maybe that determines something in the model. That certainly helps with documenting the design intent. So show with the model how those calculations are being utilized and use those calculations to help drive our analysis. And likewise, use that analysis to maybe further our design. With all this, we're really further validating our designs. So we can check a design change and have that documented. For example, if I change the inner diameter of this bore, what's that going to do to my factor of safety? Are we staying within a certain range? Now let's step over and actually see what this is going to look like over in Mathcad itself. Okay, here we go. So I'm going to jump into a document. I'm just going to jump right into this document that we have laid out here. And the first thing to notice is that this is going to be pretty simple, very similar to working with a Word document or something like that. So take things, format text, do whatever editing we need to do in a way that we're used to. And that's one of the main value points I really want to highlight in this, is that it's extremely user-friendly. It's going to take little to no time to actually get used to working with it. Even that default layout shows that grid-like paper like I mentioned, and this is a pretty good start. So now with that built out, let's dive in and start to see some of these capabilities in Mathcad. Here we're setting up a section for a beam deflection. So let's set up that diagram. You can see as soon as we double click on that picture, diagram, it's cross-referenced over in PowerPoint. So we're able to go through and make any necessary changes that we need, and those changes are going to appear right inside Mathcad as soon as we make them. Now we have this in, let's go through and do whatever calculations we need to do for this diagram. And with the natural math notation, it's the same process as we'd be doing in a notebook, going through defining variables, and once we have them all laid out, we can utilize them in our calculations. defining moment of inertia, b times d to the third, and actually we made a typo. So what's going to happen if we do this? So we can see, hey, we got all these units. What's that h maybe that we used? And h is actually Planck's constant. We were able to quickly check with Mathcad and see that's not what we're going to use. So go back, change that off to a d, and see that our calculations down the line update automatically to solve the problem. I mentioned earlier about units also. You can see as I start to define this, Mathcad's going to update the answer to reflect those units. And if I want to change them, maybe I want to go into another unit, just go ahead and do that, and the value from my answer is actually going to update with that. Mathcad won't actually let us make a mistake. So if I say, hey, I'm going to try to add seconds to meters, it's going to say, don't do that. And really goes to show how Mathcad keeps us from making all those simple errors. And most times we're going to have data from elsewhere. So there's a lot of capabilities for importing and exporting data. One option might be to utilize some data that you've gone through and collected in Excel. Well, you don't have to throw away that or retype it. Just leave it as is and just bring it right into Mathcad here. Now that we've selected the data and brought it in, we can set that equal to a matrix called data. And now I can just ask Mathcad, hey, what's that variable data equal to? And it gives me that information. And it really understands the information that's being brought in. So we can go back and change the range that we selected. And right there, we see all those values are going to instantly update in our matrix. Once we have all these defined, we can go ahead and use those in our calculations. And no need to code any of this. Just go ahead and ask maybe, hey, what's E going to be equal to in gigapascals? And boom, right like that, we have the answer. All right, here we have another graphic. So let's go through and just define some variables. First, maybe lay out some beam dimensions, say length is 15, then go through and define the load for our study and say where the load is located. Again, type in all those units. Could even mix some dimensions, inches and feet, meters and centimeters, no problem there. Now we can go through and do our calculations. And the main thing I want to show off in this calculation section is the ability to password protect a certain area. This is really important for intellectual property. Maybe you have things that are changing, only want certain people to be able to edit this. We can go through and just say, hey, let's password protect this, make sure the wrong people aren't getting into this. And here we can see all those equations I laid out for the study. Just type out as I'd have them on a sheet of paper. And with that, I can simply type in what I want to find. Say I want to find deflection at L/2. And I have my default set to meters. I can easily type that in as millimeters and get a value and the spot exactly how I need it. All right, and we could do math maybe like that, or we could do symbolic equations showing exactly how we got somewhere. Maybe we want all these calculations, but we don't want them showing up in the final sheet. Or we can go through, do the equations, derivatives, solve for x, but simply close out that region from being seen afterwards. All of it's still right in the document, but now it's hidden. Me or anybody else that needs to can go back and reference that if they need to, and we're still going to have all the information. And we'll touch on these plots in a minute. First, I want to look at how we actually view this data. Similar to how we did earlier, let's double click on that file and maybe make some formatting changes that we need to do. Make the text bold or something, maybe have it centered just to make it look nice. And when we go out and close that out, we can see that the component is updated for us. Now I want to go ahead and open up that plot data below. With this, we can see that it's kind of getting across some information. It could definitely use some work. You can see we have all our formatting options right here on the left. Don't have to go searching for maybe where we format legend versus where we format the title, all in one concise location. With that, we're starting to give context to whoever happens to be looking at the graphic. There's no need to guess, I think this blue curve has something to do with our deflection. None of that. We want accurate and concise graphics. So let's do just that. Define, say what each axis is displaying, give some value for the information that's being displayed. We have full functionality when it comes to differentiating between every piece of information from the next. So we don't want the user to be the one that has to decipher what each line means. Let's clearly lay it out for them. Edit the legend, say exactly what each thing is here, play with the line style and thickness to really add that level of differentiation between our data. Finishing up each line here, adding in whatever I feel is necessary to fully define the results of my study. And these multi-line features is something that was really only made possible with the latest release of Mathcad 5.0. Okay, and so looking at this, I've built out my legend, and I really like the way this looks. It pretty much tells everything that I want to say with my information here. You also have some further calculations laid out in the appendix, and what I really want to do is take a closer look into a graph at the bottom here. This is a 3D graph that we can actually edit live, and has the same ability to format and color like we did with the 2D plot. We can also see that we can rotate this around, move the graph, and really show the view that we find the most meaningful. Can zoom in and really start to interrogate any element of the model that we actually want more information on. So we have full functionality with that. All right, with that, we've fully documented every step of my engineering design process in a clean and efficient way. All right, so stopping back into the deck, let's take a closer look into some of the enhancements that we have with some of these recent releases of Mathcad. First, with Mathcad Prime 4.0, we first have some performance enhancements, specifically when working with Word documents, Excel data, also beefed up our plotting abilities like we just saw, able to plot a lot of more points much more effectively now. We saw our ability to password protect certain areas, touch more on that in a minute, and let's actually just jump right over into there. So with content protection, I want to take a closer look into this. So any area that we're worried about, we have full disclosure there. I have an option to add in a password protection or simply leave it unprotected. Could also have the option to have a timestamp required for accessing certain areas. Another option is the ability to simply lock the display state for certain regions. That means we can either have something locked open so everything's visible, locked closed so everything's hidden off, or just simply leave it with no area lock. That's all up to you. And touching on Mathcad as an OLE container, that's what I mentioned with double clicking on the PowerPoint image. So instead of having to search through my computer to go ahead and open up a file that I'm interested, just have the program open that up automatically. And the same thing went for whenever I clicked on that Excel data. It's the same type of thing. Here's what we're talking about when we're able to copy and paste multiple regions into other applications. So if for some reason we needed to share this data off and bring it over into, say, a Word file, for example, all you have to do is say, keep that source formatting from Mathcad, and we can take those different regions and copy them over. And it's going to look exactly like we did over in Mathcad. Jumping over into a little bit of what we brought in with Mathcad 5.0 here. That really is revolving around plotting options is what I want to discuss. Like we saw in the presentation, we can have multiple y-axis on the same plot. And we really built out a lot of different options for editing the plot, essentially anything that you need to do there. That includes different text options such as fonts and style choices. A few more points going on here. We have the ability to add value markers and grid lines for our graphs, add in plot and axis titles right in Mathcad, give the users a bit of context for the graph. Finally, make any kind of edits to the legend or any data lines that we see fit. Moving forward with Mathcad, we're really ensuring that our intellectual property and ensuring that our knowledge is not being lost between people or different teams. All that information is easy access and easy to understand. Now fully optimizing our designs as well, because we can reference every part of the design process and ensure that each step that we took was actually done in the best possible way. Overall, we're improving the quality of our designs. No errors slipping through the cracks, because we actually understand each variable that's being used in the process. We have all these equations and we have a system of equations maybe laid out, we can reuse that system. And it's so much faster than if we just did that all out by hand on a notebook. Again, it cuts out the risk of making an error that might be occurring if it was done by hand or done by somebody with pen and paper. And possibly the greatest value we see here is in regards to compliance. So more and more today, we have to lay out exactly everything that we did and show exactly what we did at each step in the process. Now with doing all our calculations in Mathcad, we're able to show that off to anybody, whether it's internal or external. And that's really the last piece of the puzzle with Mathcad. We've done all of our solving and analysis. It's been documented and stored. So now we're ready to collaborate and share that design off with anybody and everybody. And on my side of things, that's really all I had to go over and discuss with everybody today. And so I'll hand it back over to Jenny to finish up.
Yeah, actually, I'll be finishing up, but thank you so much, Paul. I don't see any questions, but I do want to mention that right now we have a buy one, get one 50% off when you commit to a 2-year subscription with Mathcad licenses. This also applies to seats of Creo if your team is looking to add more seats for your CAD needs. This offer is only valid through the end of September, so jump on the offer now before it's too late. I'll also send the link you need to find more information about the offer in the follow-up email I'll be sending out. There's also a short 4-question survey that will pop up here once we end the webinar. Please take the time to answer the questions, and we would really appreciate it. So thanks again for jumping on, everyone, and have a great rest of your day.